All right, so let's get back to the octet rule. So those outer shells are most stable when they're surrounded by pairs of electrons, when they're full, essentially. And so at least when we're back to our kind of biologically relevant atoms here, which all have 8 in the outer shell, those outer shells are going to be most stable when the outer shell is full with 8 electrons. And so valence basically is the number of electrons required to get to full. All right, so oxygen here has 1, 2, 3, 4, 5, 6 out of 8 in its outer shell, and its valence is 2. It would need 2 more to fill the octet rule 8 in its outer shell. Nitrogen only has 7, or sorry, 1, 2, 3, 4, 5. It has 7 total, but 5 in the outer shell. So in order to get to 8, it needs 3. It's basically missing 3 electrons to make sure it has its octet rule filled. And then carbon, with only 4 in the outer shell, 6 total, because you have to include the inner shell, with only 4 in the outer shell, it needs 4. Its valence is 4. And we can kind of tell that here. We can tell that carbon needs 4 because it's right here. It's 1, 2, 3, 4 away from the end. These are the noble gases, meaning they're stable because their outer shell is already full. Helium doesn't react, neon doesn't react, the outer shell is already full. However, fluorine does react because it's going to try and get its outer shell full. Its valence would be 1. It needs 1 to get there. Oxygen's valence would be 2. It needs 2 to get there. Nitrogen's valence would be 3. It needs 3 to get there. Carbon's valence is 4. Boron's 5, and so forth. All right. This is important because this is going to determine how many bonds these atoms make. So at least when we get to the idea of covalent bonds, what you're going to learn is that the way nitrogen is usually going to fill its outer shell is by sharing electrons, and it needs to share 3 electrons total in order to get to its 8 because its valence is 3. That's why nitrogen will make 3 bonds. Carbon, with its valence being 4, actually needs to make 4 bonds in order to get its outer shell full. It needs to share 4 electrons. So how many would oxygen need? So how many bonds is oxygen normally going to make? Well, oxygen would make 2 bonds because it only needs 2. Its valence is 2. It only needs 2 electrons to fill its outer shell, so it will have to share 2 electrons, meaning it will need 2 bonds. Hydrogen's unique. Its valence is 1 even though it only has 1 in its outer shell. Remember, hydrogen is up here in this row. Its outer shell, which actually is the innermost shell of most of these, its outer shell only needs 2. So its valence is 1 because it's only 1 away from having its shell, its unique shell filled. Right? So hydrogen will make 1 bond to share 1 electron to fill its outer shell. All right, so there are 2 ways that an atom can make its outer shell have its full set of electrons. If you're over here, it's much faster and much easier to gain electrons to fill your outer shell in this direction. So fluorine would have to only gain 1 extra electron, its valence is 1, to fill its outer shell. Otherwise, it would have to lose 1, 2, 3, 4, 5, 6. If it lost 6, its outer shell would be full, but that's much harder for it to do. On the other hand, if we're over here, it's very hard for sodium, which only has 1 of its 8 in that outer shell. It would have to gain 7 to get to a full outer shell here, or it can just lose 1. And so it's much easier for sodium to lose 1 electron, and we already learned if sodium loses 1 electron, what's it going to become? Well, if sodium loses electrons, it is going to become a positively charged ion. And how many electrons does sodium often lose in order to have its outer shell filled? Well, it's going to lose 1 because that's all the extra electrons it has in that outer shell. On the other hand, let's look over here at calcium. Calcium would have to lose 2. It has 2 in the outer shell. It will lose 2. That's why calcium's charge often is 2 positive charge. Right? So we can look here. Calcium usually has a 2 positive charge because it's going to lose 2 electrons, 1, 2, to get to its outer shell being completely full without extra ones in its case. Right? So calcium will lose 2 to get to the closest octet rule. Chlorine will gain 1, giving it a negative charge to get to its octet rule. Right? Here's chlorine, will gain 1. So chlorine ions are usually 1 negative charge. Calcium ions are usually 2 positive charge. Hydrogen often will lose its 1. Magnesium is going to lose 2. Here's magnesium. It's in this column, so it's going to lose 2. Potassium is in this column, so it's going to lose 1, just like sodium. All right, so there's potassium's charge, there's sodium's charge. So that's the answer to why do some cations consistently have a +2 charge while others have a +1 charge. So in Edpuzzle, go ahead and answer that question now. Just give me a very brief explanation of why magnesium has a 2+ charge, but sodium has a 1+ charge, whereas chlorine has a 1- charge. This can be a very short few sentences, but just try to put that into words if you were asked this on an exam. All right, so hopefully you were able to talk about how the fastest way, or easiest way to the octet rule for chlorine is to gain one charge. For sodium and potassium, it's to lose 1, and for calcium and magnesium, it's to lose 2. Because of where, and you know that by where they are in the periodic table. Bring your questions on that to class and let me know if you have questions, or come to office hours. I'm more than happy to help.